So welcome to the chapter 2 of the O-level chemistry. This chapter we will be talking about the experimental techniques for you to separate different chemicals. Before we get into that, we must first have a knowledge on what is some of the apparatus that we'll be using here. The first one we will talk about is beaker. It's very commonly seen in the lab. It's used to collect volume up to 100 cm3 or more. So it goes from 100, 50, 25, so far and so on. The next we will be looking at measuring cylinder, which is more accurate than the beaker. This will be collecting volumes such as 54, 53, 52, 51, 1, 2, 3, 4, 5. And for beaker, usually we'll use to collect residues from separation techniques. The residues collected will be using beaker. For measuring cylinder is when we want to measure a certain amount of volumes that will be used in the experiment. The next we will look at burette. Burette will collect up to plus minus 0.1 cm3. And you see there's a tab here. So what you do is that you can slowly open the tab to release the liquid inside. This is usually used in the process of titration. And the next one is also used in the process of titration. It's called pipette. Pipette measures up to a fixed amount such as 25 cm3 to 10 cm3. It will be held here. You need something like a tube to actually suck up the liquid into this. So next we will move on to the methods of collecting gas. Before I can go further into this, please read up on your textbook, chemistry textbook, whereby there will be a page whereby it will tell you the whether which gas are dense, less dense, slightly dense, and also its solubility of the gas. You must first have the knowledge of that before we can move into the methods of collecting gas. So if let's say for example I have a gas that is dense, that's very dense, so you will sink. So preferably the best way to collect is using the downward delivery, because gas will go in here and it will rest inside here. And for gas that are less dense, you cannot use this method already, because if it's less dense, you use this method, what happens is that the gas will actually escape out. And for the gas that are less dense, preferably we will be using upward delivery, whereby gas will go in here and it will be trapped inside here. And the next method, for gas that are insoluble, you will be using displacement of water, so that the gas will enter here and it will go through the water. Because it's insoluble, so it will not dissolve in water, it will be collected here. And for universal collection of gas, I will preferably advise that you write using a gas syringe. It's the best way and the most easier way, if the question did not specifically say that what are the methods that you can use to collect that specific gas. So basically you connect the gas supply into this gas syringe, and the gas supply once comes in, you will push this back. So next we will move on to the drying of gases. You know that gases will be actually divided into acidic, neutral, and alkaline. These are the three types of gas which we will further talk about in the future chapters on acid. And to collect acidic gas, you will be using this method here. You will fill this thing with H2SO4, concentrated H2SO4, and you connect a tube into the H2SO4. And remember, it must touch the H2SO4, because if it doesn't touch the gas, if it's less dense, it will not reach the water. So what happens is that moist gas will go in, and if the gas are alkaline, you will actually react with this acid. And those that are acidic will manage to come out as dry gas. And for collecting of alkaline gas, you will be using this method. What happens here is that the moist gas will actually enter, and those that are acidic will actually react with this quicklime, which is calcium oxide, under an acid-base reaction, and what's coming out is the alkaline gas, which is dry. So next we will be looking at whether a substance is pure. A pure substance has one unique quality, and that is that it has a sharp and fixed boiling point and melting point. So for example, I'm talking about liquid water, pure water. Pure water will usually have a boiling point of 100 degrees and melting point of 0 degrees. That's what I mean by sharp and fixed, because it's 100. So if let's say I add a bit of salt into the water, you're making it impure. So what happens is that now the boiling point will be over-arranged. So usually if you add impurities, you will tend to increase the boiling point. So now the boiling point of water might range from 99 degrees to 102 degrees Celsius. So this is what I mean by over range. And you also tend to lower the melting point. So from 0 now becomes 0 to -1. So it's over a range. We are not sure what is it. So now we will be looking into the different methods of separation. Before that, we need to understand a few terms. Miscible, immiscible, soluble, and insoluble. Miscible means that the liquids can be mixed together. Two liquids can be mixed together. Immiscible means that they cannot be mixed together and they will separate by layers. So for example, oil and water. Soluble means that it can dissolve in water to be part of the solution, and insoluble means that it doesn't dissolve in water. So let's look at the first method, the most basic method. If I have a beaker filled with water and rocks, like this, and I want to separate the water from the rocks, what should I do? The most common sense method is that you actually pour out the water apart from the rock, and hence dry the rock, and that's it. You will be able to separate the water from the rock. So this is actually a method that in chemistry we call it decanting. And let's look at method 2. The next method is something similar to this, however it's for substances that are insoluble but at a smaller particle size. So for example, and this process is called filtration. So what happens is that inside this beaker, it contains the insoluble solid particles and liquid. And this is a filter paper. And what happens is that if you pour this in, the residue will stay on the top. So what happens is that the residue will actually start on top, which is the insoluble solid, and the liquid will actually go through, and this is known as the filtrate. So one of these examples can be barium sulfate together with NaCl. NaCl aqueous will be a liquid form, while barium sulfate is an insoluble salt, hence it will exist as white precipitate. So you can actually use this method to separate barium sulfate from NaCl solution. So the next method we will be talking about is crystallization. Crystallization is to separate a soluble solid that is dissolved into water. So what we do is that the solution will be first heated to saturation. It will be left to cool, and a crystal will be formed. Saturation means you heat until it becomes black. You can see that there's a black layer at the bottom, and all the water are gone. So next we filter out and washed with distilled water. So after it has condensed to be a crystal, we wash it to remove some of the impurities with distilled water. So next we will be moving on to the simple distillation. Simple distillation is a process whereby you want to separate two miscible liquids that are mixed together. However, these two liquids or these two solutions has different boiling point. For example, let's look at NaCl and NaOH. NaCl and NaNO3. So this is actually a setup for the simple distillation, and what we have inside here is a big boiling shape. A boiling shape is to ensure smooth boiling. What do I mean by smooth boiling? This is the boiling graph. If this is actually considered smooth boiling graph, and if you have an unsmooth boiling graph, it might look something like this. So that's why we add in this boiling shape to ensure smooth boiling. And here we have a condenser. This condenser is to condense the vapor of the liquid that you are separating back into its liquid form and be collected in this beaker. So what happens is that this conical flask contains the two solutions that are miscible, that are mixed together. So the one with the lower boiling point will actually escape out as vapor, and hence condense in this condenser to be collected as liquid in this beaker. Do bear in mind that this is simple distillation. The difference between simple distillation and fractional distillation that I will be covering in a minute's time is that this simple distillation is for us to separate two miscible liquids that has a very huge difference in terms of their boiling point. Remember, you must have a very huge difference in terms of boiling point. For example, water and NaCl. Water might have a boiling point of 100 degrees, while NaCl might have a boiling point of 70 degrees. The next process we'll be looking into is called sublimation. Sublimation is for us to separate things that can be sublimed with those substances that cannot be sublimed. So basically this is the setup. You'll heat it until the one that we want to collect sublimes, and it will cool on the surface here. And once that is ready, you can actually collect it into another beaker or plate, whereby those are the crystals that are sublimes. And this wet towel is to help to condense them back into the solid form that they are. So let's look into fractional distillation. This is fractional distillation. It looks very similar to the one we see on top, which is simple distillation. However, there's a few more addition features, such as a fractional column or glass bead. This is to help to condense the liquid that is not supposed to leave back into the conical flask. As I said, fractional distillation is for us to separate two liquids that have very close boiling point. Hence, this is an important feature to have. If not, because they are so close, they might just boil off together and escape into the condenser and condense off back into liquid form. Then it defeats the purpose of that. So this is for fractional distillation. And one more thing to take note, that for the condenser, water will go in from the bottom and comes out from the top. There's a special reason why this is so. If the water comes out, if the water, for example, goes in from the top and comes out from the bottom, it will not be able to cover the entire thing. You'll just go through like this. However, if I go from the bottom to the top, I will ensure that my water will cover this entire thing. Hence, increase the surface area of cold water to help to condense the vapor. So please take that in mind. Please bear that in mind, sorry. The next process we will be talking about is the separating funnel. The separating funnel is for us to separate immiscible liquids such as oil and water. So what happens is that by nature, if you pour them inside, they will float on top of each other due to the difference in density. And once you open the cap, you will drain out the one at the bottom, which is less dense, and you will come out and you will stop. You will turn the tap slowly until they left a few more drops, then slowly drop by drop and let it off. Then you close the tap, and that you will collect the first liquid, and the second one you just open everything and collect into another beaker. And for the next process, which is very important, is used in testing of food dyes, food color, and the substance inside our food, so that to ensure the safety of food qualities. This is called paper chromatography. Paper chromatography works based on the solubility of the substance. So the more soluble it is, the higher or the faster it travels up the chromatography paper. So for that, we need to calculate whether the RF value. How do we calculate the RF value? It's actually the distance by the substance over the distance traveled by the solvent. So this is the setup. This is the solvent front, and this is where the dye starts. So you will start to travel up, and this distance here is known as the distance traveled by the substance, and the distance from the pencil line to the end is actually known as the solvent front. So from there, we can actually find out the RF value. So please bear in mind that I wrote here is pencil line. Why is it we use pencil line instead of lead? It's because if you use lead, and when this dissolves into water, lead will actually soak up. The ink will also dissolve, hence will make the experiment inaccurate. And also bear in mind that there is a chance that the dye might be colorless, and if that happens, we need to use an indicating agent. So with that, we have come to the end of our chapter 2. Thank you.